Hey there, welcome back to another video by ChemEnggLife. As we are moving every day closer to a data-driven world, we bring to you the top 10 hard skills that chemical engineers need to be able to work in data analysis. So watch the video till the very end, and if you do like it, then do not forget to like, share, and subscribe to ChemEnggLife channel for more videos. Let's begin. The skill that we have in number 10 is communication skill. And that's because collaboration is a vital skill in data analysis, as chemical engineers frequently will work with cross-functional teams alongside data scientists, software engineers, business stakeholders, and also other chemical engineers. Therefore, beyond the technical expertise, soft skills such as communication, teamwork, project management, are essential for understanding data team workflows and effectively sharing technical insights among the team. And these skills enable chemical engineers to explain complex chemical processes and integrate their expertise seamlessly into a data-driven project. The skill that we have at number 9 is simulation and modeling. Simulation and modeling involves using software like Aspen+, COMSOL, Multiphysics, or Python-based tools to replicate chemical processes and evaluate the system performance in a virtual environment. These skills allow chemical engineers to test scenarios, predict the outcomes, and optimize process conditions without the risks or costs associated with real-world experimentation. And simulations are indeed invaluable in data analysis because they help chemical engineers validate models, explore what-if scenarios, and also combine experimental data with process insights for deeper analysis. Therefore, as chemical engineers who can master these tools can save themselves time and resources while making more informed, data-driven decisions. The skill that we have at number 8 is predictive and prescriptive analytics. Now, predictive analytics uses historical data to forecast future trends, while prescriptive analytics provides recommendations for optimal decision making. Now, both techniques rely on advanced modeling methods and statistical tools to help make data-driven predictions and suggestions. In chemical engineering, these skills are crucial for improving production efficiency, reducing waste, and maintaining product quality. For example, predictive analytics can be used to forecast equipment failures, predict process yields, or assess market demand. Meanwhile, prescriptive analytics can help chemical engineers optimize processes, recommending adjustments to maximize efficiency or minimizing the waste. And these analytics techniques allow engineers to anticipate future conditions and take proactive steps to optimize the operations. The skill that we have in number 7 is data cleaning and pre-processing. Data cleaning and pre-processing involves preparing raw data for analysis by removing errors, filling in the missing values, and standardizing formats to ensure data quality and consistency. Chemical engineers frequently work with messy, incomplete, noisy data from experiments, simulations, or industrial processes, and without proper cleaning, the data can easily lead to inaccurate or misleading results. Hence, therefore, mastering this skill is essential for ensuring the integrity of analysis, allowing engineers to produce reliable insights and make data-driven decisions based on accurate and consistent information. The skill that we have at number 6 is process data analytics. Process data analytics involves examining data from chemical processes such as temperature, pressure, and flow rates to optimize the performance. On the other hand, sensor data interpretation focuses on analyzing signals from sensors used in monitoring and control systems. Chemical engineers often work with this type of data to monitor operations and ensure that processes run smoothly and safely. And by analyzing process data, chemical engineers can very easily detect inefficiencies, predict equipment failure, and refine production parameters to optimize outcomes. This skill is especially crucial in industries like petrochemicals, pharmaceuticals, and food processing, where process optimization is key to maximizing profitability and ensuring safety of the engineers. The skill that we have in number 5 is database management and SQL. Structured Query Language, also known as SQL, is the standard language used for accessing and managing data in relational databases. It involves organizing and maintaining data to ensure easy retrieval and analysis. For chemical engineers, SQL is essential for extracting meaningful insights from structured datasets such as experimental results, historical process data, or supply chain information. So therefore, having proficiency in SQL enables engineers to efficiently query and manipulate data, streamline workflows, and facilitate seamless integration into analysis processes. This skill is foundational for managing data pipelines and ensuring that critical data can be accessed and used effectively in chemical engineering projects. The skill that we have in number 4 is big data tools and platforms. Big data tools such as Hadoop, Apache, and AWS are specifically designed to process, analyze, and manage large-scale datasets efficiently because they allow you to handle the volume, velocity, and the variety of big data. In chemical engineering, especially in large-scale operations, processes generate massive amounts of datasets. And these big data platforms enable engineers to store and analyze this data in real time, which can help them uncover valuable patterns and optimize the systems. For example, engineers can use big data tool to analyze data streams from multiple reactors or production units, enabling them to detect inefficiencies and make informed, data-driven decisions to improve the performance and productivity. The skill that we have in number 3 is data visualization and reporting. Data visualization is the graphical representation of data using tools like Tableau, Power BI, Python, or even Excel. It involves creating clear, impactful visualization and dashboard, as well as summarizing findings in easily understandable format for the stakeholders. Chemical engineers frequently need to present complex datasets and insights to colleagues, managers, or clients who may not necessarily have the technical expertise that they have. Therefore, by mastering data visualization, chemical engineers can very easily and effectively communicate key information in a way that enables better decision making. This skill bridges the gap between data analysis and actionable insights, ensuring that findings lead to meaningful improvements. The skill that we have in number 2 is statistical analysis and machine learning. Statistical analysis involves numerical data to identify patterns, trends, and relationships, whereas machine learning uses algorithms to build predictive models and automate decision-making processes. For chemical engineers, understanding statistics is essential for analyzing data trends and making informed decisions, whereas machine learning provides the ability to forecast outcomes and optimize the processes. For example, machine learning can predict yield improvements, whereas statistical analysis can assess the significance of experimental data. You put them together, and these skills enable engineers to move beyond descriptive analytics and focus on prediction, optimization, and improving the overall system performance. And finally, the skill that we have at number 1 is none other than programming and scripting. Programming and scripting involves writing code to automate data processing, perform analysis, and build computational models. Chemical engineers commonly use programming languages like Python, R, and MATLAB for these purposes. These languages are powerful tools for managing and analyzing large datasets, enabling engineers to clean, process, and interpret data efficiently. Programming is particularly relevant for chemical engineers because they often deal with vast amounts of data, and therefore, by mastering programming, chemical engineers can automate repetitive tasks, extract meaningful insights, and develop custom tools to address complex data challenges. Python's flexibility, R's focus on statistics, and MATLAB's engineering applications make these languages indispensable in chemical engineering data analysis. So these were the main skills that we feel are the most relevant for chemical engineers who wish to work into data analysis roles. If you agree or disagree, then do tell us in the comments below. And learn more about Chemical Engineering Life at our website at www.ChemEnggLife.com, where you can very easily learn more about our different initiatives. And also, do not forget to like, share, and subscribe to Chemical Engineering Life channel for more videos. Thank you and have a great day.